Hi, today's notes is on 12.4, so 12.4, which is ellipses, Ellipses. Ellipses I really find to be fun. I kind of look at them like they're a fun math challenge, and you're going to have kind of two groups of people. Some people really just can't stand ellipses. Some people, if you can look at them like a fun challenge, they're enjoyable. What's nice about them is you have the same equations that you use every time, but depending on what information you're given, you need to try to figure out different ways. So that's where I enjoy it. But first thing, before we even get into that, I want to say, well, kind of the definition of an ellipse. So definition of an ellipse. And what that is an ellipse is the set of all points in a plane. So the set of all points in a plane that are the same total distance from 2 points. So an ellipse, the set of all points in a plane that are the same total distance from 2 points. And those 2 points, it's kind of like we have distance-wise, we're talking about parabolas a few sections ago, and we had the same distance from the focus and from the directrix. Now we have 2 points, so we have 2 focuses, or when we talk about those are referred to as foci, F-O-C-I. That's going to be the plural for a focus. I want to go through and show how you could draw an ellipse. I have this pink string here that hopefully shows up on the screen, and with this is going to be like the total distance that the object has, and I need to go and put a couple foci as well. So if I take and maybe say this here is going to be one focus, and then this would be another focus. If I have those in a horizontal line, then I'm going to get what's called a horizontal ellipse. I'll do the second example as a vertical ellipse. And since I'm doing total distance from there, I'm going to take and tape my string on one of those foci and tape the other end of my string on the other focus. And now this here is going to be that total distance. So in order to get it to work, every point on my ellipse has to have the same total distance from both foci. So right here is going to be one point on the ellipse. Over here is going to be another point on the ellipse because that total distance is the same. So I could go through and try to draw them. And if I do that, now all of these points should have approximately that same total distance away from my 2 foci. So I get an ellipse that looks something like that. So each point, same total distance from the 2 points. If I wanted to, I could also then have a vertical ellipse. For a vertical ellipse then, we take and we have our foci be vertical. And I could go with the same length for my focal constant. I'm going to make it a little bit longer. And if I do this now, actually I'm going to take and put my foci a little bit further apart as well. And put it down there for my other one. Or basically we're kind of getting a circle that's a little bit stretched or squished depending on your perspective. You may think of like the elliptical orbits of the planets. The planets all follow an elliptical orbit. Now if I have this here, I have my new focal constant. I try to keep that same total distance the same from both points. And right there then I have another ellipse. So it's a little bit more elongated than my first one was. And I have my 2 foci. So that's really how they go through and make ellipses. Alright, so now I want to continue on in my ellipse notes. And first I want to talk about like standard position for an ellipse. And when we have an ellipse in standard position, it's going to be something like that. Basically, it's centered on the origin. And your foci now will either be on the x-axis if it's a horizontal ellipse, or they'll be on your y-axis if it's a vertical ellipse. So in this slide, I want to mention that the origin then is going to be midway between my foci. So if one of them is over, looks like 4.5 to the right, the other one would have to be 4.5 to the left, or same if they were up and down. The center is at the origin. And now I want to talk about the major axis and the minor axis. If you think of like people in your life that you know that are jerks, major jerks are bigger of a jerk than a minor jerk. Same thing for your major axis and your minor axis. That your red thing here then, the longer one, is going to be the major axis. On a horizontal ellipse, one like this, it'll always be your x-axis, and it goes from the furthest left point of your ellipse to the furthest right point of your ellipse. If we had a vertical ellipse, like that second one I drew on the board, then your major axis would now be on your y-axis, because that would be the longer one. Your minor axis then is going to be the shorter of the two, and the blue doesn't show up as well. But essentially it goes from the maximum y value to the minimum y value. So this would be the minor axis. And again, if we had a vertical ellipse, now that would be switched. That'd be the shorter one, which would be on the x-axis. Your foci, often they'll call them F1 and F2, although we're going to assign letters for everything. Just like we had in our non-right triangles, we had angle A, side A, angle B, side B, and so on. Your foci, we're going to call those C. And that actually comes up on my next equation. But for now, just f sub 1, f sub 2 for my foci. The distance now, if I were to pick, this is kind of like my pink string, for any point on my ellipse, I should be able to take and say, well, the distance from one foci plus the distance from the other foci to that point, that those two together are going to give me my focal constant. So you could, if you wanted to say, those two things added together, the sum of those, kind of the add them together, equals the focal constant. And that is going to be the same as the major axis. If I would take these green things, actually let me pick a different color. I'll go maybe with a red dashed. If I were to pick this endpoint over here and look at, well, what about that focal constant, the total distance from each point? You would agree, have it up a little bit just so I can see it, but that focal constant, the total length of the greens, would be this one here plus that one there. That if I have this point on my unit circle, it's the distance from the closer foci, focus, plus the distance from the further one. Well, if you look, I've doubled up in this little part right here. That top one's doubled up. If I take and move that over there, do you see how the focal constant then, that distance, the length of your string if you're drawing it, is going to be the same as the major axis. So I could then continue to write over here focal constant equals the major axis, and if I were to, focal constant equals the major axis, and we will come back to it after that. So standard position, I guess this is backing up. I probably should have wrote that at the beginning instead of just saying it. The origin, or 0, 0 on your coordinate graph, is midway between F1 and F2. Also then, F1 and F2 are on, maybe I'll say an axis. F1 and F2 are on an axis. Could be on the x-axis, could be on the y-axis. You could also, if you wanted to, say center at the origin or center at 0, 0. But that's kind of redundant because if the origin is midway between the two foci, then it's going to be centered at 0, 0. Alright, last thing I want to do on this one, and I probably should have done it at the very beginning, but want to write out the equation. So the general equation for a parabola, pretty much all of our parabolas are going to be in this form. All of them will be unless we have one on some crazy angle, and we don't want to go there. So x squared over a squared. So a is going to have something to do with x, plus y squared over b squared. So b is going to have something to do with y, equals 1. So x squared over a squared plus y squared over b squared equals 1. And these equations probably should flip down and look at the equation sheet thing in the Moodle, or start writing some of these equations down on the index card you've been using in this chapter. We want to jump over here, and now we're going to label some parts of an ellipse. So I'd grab a new ellipse or write down a new ellipse, otherwise the one you have is going to get pretty cluttered. We said that a has something to do with x, and a is always going to be the largest x value. So that point right there, the x value is a. You could, if you wanted to, write a comma 0. I'm going to just say that it's a though, and that point's a. If you wanted to, you could label this then, as long as we have our ellipse in standard form. If this is a, the largest x value, the smallest x value has to be a negative a. B was underneath the y squared. So b then is going to be related to y. B will always be the largest y, or the maximum y, which then would mean that we'd have a negative b down here at the bottom. And our foci are going to be c, so c and negative c. And those are always going to be true whether you have a horizontal ellipse like this or a vertical ellipse. But this here would be a vertical ellipse. You'll notice that a is still the largest x value, negative a then would be the smallest x. B is still the maximum y, negative b would be the minimum y, and now c is our foci, the positive one, negative c would be the negative foci. And really the difference there is going to be that now for c, instead of it being c comma 0 like you had back here with a horizontal ellipse, maybe this point here would be, how far over am I? So 1, 2, 3, 4.5. So that'd be 4.5 comma 0. Now you're going to have c being 0 comma 4.5. But still c is going to be the foci. And the foci are always on the axis, the major axis, the axis in the direction that the parabola is longer. Okay, so now I want to flip over to where we're doing a bunch of different examples. And I may have this already in Moodle, I may have given it to you already, but what you should do, at some point I'd quick pause the video and copy down this stuff right in here, the ellipse stuff. And these are going to be equations that we come back to. A couple comments on them. One, I have both ellipses here, so I drew out where a horizontal ellipse where A, B, and C are. Did the same thing for a vertical ellipse. And the equation for an ellipse is this top thing, the x squared over a squared plus y squared over b squared equals 1. Now this equation here, if you're writing frantically, I'd stop writing, listen a second. But this here is going to be the equation that you use whenever you need to go from knowing A and B, kind of the end point, so to speak, of an ellipse, to find the foci, or one of the focuses, or of focus. Or if you know the foci and either A or B, you can get the other A or B from that. The focal constant is letter D, and the focal constant we said was equal to the major axis. That's why I wrote down it's the larger of 2A or 2B. If you have a horizontal ellipse, the focal constant, major axis, is going to be twice A, because you have A here, and you have another A here. So focal constant is going to be 2A, divide the focal constant by 2, you have your A value. If instead we have a vertical ellipse, now the major axis is vertical, so your focal constant is going to be 2B, because you have B there and B there. Divide your focal constant by 2 and you have B. Alright, so pause the video if you haven't, and copy these things down. This last disclaimer, this area, that's actually from 12.5 that we may be doing this year, we may not. Alright, so by now you hopefully have all that done. I'm going to go over some examples, and this is the part that I really kind of find enjoyable, because like I said before, you always kind of start in different places and you have to kind of work backwards to get what you want. The first couple aren't nearly as fun, but let's go from here. Okay, so if we have to graph this, one good place to start is to first, and especially until you get good, is to write out that general equation right underneath the equation they give you. So x squared over 36, that's the same as x squared over a squared. Y squared over 81 is the same as y squared over b squared. So now if we want to find the four vertices are going to be the four like endpoints, if you could call it that, the maximum and minimum on the x-axis, the maximum and minimum on the y-axis. So if we look at this, you'll first notice that this number here, the 81 under the y squared, is larger. So we're going to have a vertical ellipse. And for that you could say, well, maybe I'll start with a, that if a squared is 36, we have two possibilities for a. A could be 6 or a could be a negative 6. And the way that you'd find that, going back to chapter 6, if you wanted to find a, and when it works out nicely like this, most people wouldn't do this in their head. You would just do this in your head. But whenever you do the square root of a variable squared, you have to do absolute value. So then a in here, that could have been a positive 6, or it could have been a negative 6 there. So my maximum on my x-axis is going to be 6, so 1, 2, 3, 4, 5, 6. The minimum is going to be 6 as well, like so. And now you could do that same thing if you wanted to find the maximum and minimum on the y-axis. So what squared is 81? That's going to be 9, so we'll be up 9. So we have 3, 4, 5, 6. And then negative 9 would be down here. Now for drawing them in, honestly, I'm better in real life than I am with this little tablet thing. But if we take this, I would just try to draw something that kind of looks elliptical through those points. And if it looks like you put some effort into it, you're going to be fine, at least in my class. So you don't need to go through and try to figure out what's the y value in x is 2, what's the y value in x is 3, and so on, and connect all these points. Let's try to make a decent looking ellipse through those 4 vertices, those 4 maximums and minimums. So something like that. And in a perfect world it'd look a little bit more symmetrical, but as long as it looks like you put some effort into it, I'll grade you well. So that's my first example. Second example is that same sort of thing backwards. So a lot of these now we're getting to where write an equation for the ellipse. So what I try to convince people to do is first write out the equation. So we have x squared over a squared plus y squared over b squared equals 1. And this is where, as you do these, please keep that index card handy, that thing with all the ellipses, because I'm hoping that, if you keep that handy, the questions will be a whole lot easier. So I'm going to scroll that a little bit to the top. So my ellipse section right there. Alright, so I'm going to jump back to here. And now our equations generally have an x and a y in it, so we just need to figure out what's my a and what's my b, and then put them in there with them squared. Alright, so my a is always the largest x value, so we have 1, 2, 3, 4, 5, 6, 7, 8. So then a is right there, a is 8. So a squared must be 64. Plus my y value is 4. So then b has to be 4. So y squared over 4 squared, so 16, equals 1. So that would be the equation for the ellipse given there. Alright, so my next example. Write an ellipse, or any ellipse has a vertical major axis of 14, a minor axis of 4. Write an equation for the ellipse. Please, 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 take the story problem, draw out what the ellipse is going to look like. It makes it infinitely easier. So when we see this, an ellipse has a vertical major axis. So that's a lot of times the first step is figure out, is it going to be vertical or horizontal? So I found I do better if I just kind of draw in a roughly elliptical shape. That's very roughly elliptical. But if I draw it in first and then try to throw my x and y axes in there, kind of after the fact, it turns out better. Kind of begs the question, what does it look like when I do my axes first? But okay, so an equation has a vertical major axis, so we know that that's going to be what it looks like. Now my a value is going to be there. I guess I'm getting a little ahead of myself. Alright, vertical major axis of 14 and a minor axis of 4. Write an equation for the ellipse. So if I start out with, alright, what am I trying to fill in? Anytime you're trying to get an equation, we really just need to know what a and b are. Because if we have x squared over a squared, put in a and square it, put in b and square it, and we're done. Okay, so for this vertical major axis, we know this whole thing here is going to be 14. So if that whole thing there is 14, we also know now that the number up here at the top is going to have to be what we call letter b, which then goes here in our equation. So if the whole length is 14, b then has to be 7. The only way to get 14 is to be up 7, and then down 7 gives us 14. So in our equation we could say y squared over 49, which is the 7 squared. So that doesn't seem too painful. Now this next part, the minor axis, well, minor axis is always going to be the shorter one. So minor axis is going to be that length right there. And we know that in green is 4. And that can tell us what A is, because if that whole green length is 4, A has to be a 2. Because we'd have a 2 here, and then on this side we'd have our negative 2. So it would be x squared then over 2 squared, so x squared over 4, plus y squared over 49 equals 1. And that there would be the equation for the ellipse. But drawing it out, I put this on the quiz last year, and it was a bloodbath. But most of the people that had it wrong didn't take the time to draw out what the ellipse looks like. Alright, example 4. An ellipse has foci of 8, 0 and negative 8, 0. It goes through the point 0, 6, write an equation for the ellipse. Alright, so first thing now is it vertical or is it horizontal? And the 0, 6 doesn't tell us anything about that. The hint comes in where the foci are. That if we would take and do these foci, these are both on which axis? The x-axis. And we said that the foci are always going to be on the axis where the ellipse is longest. If we look at our little drawing, here my foci are on the x-axis, I have a horizontal ellipse. Here my foci are on the y-axis, I have a vertical ellipse. Alright, so going back to here, we know then that my ellipse has to be horizontal. It has to be wider than it is tall. So I'm going to try to draw one of those a second. So something like that, a squish circle that's horizontal. Then from there, if I aim to get my axis kind of through the middle, and take and move that up a little. Yeah, my drawings are pretty bad in here. Alright, so I have that. Alright, now what can we figure out from there? Well, the foci are going to be inside, so I'm maybe going to put something right there, a dot for my foci, and figure out your letter. That the letter is going to be C, and C then is going to be 8. The next thing that it tells us is that we have 0, 6 as a point, so kind of where on my ellipse is the 0, 6? Well, that's over 0, up 6. So in other words, they had to have just given us that very top value there for y. And if we think about that, what letter is that? Well, the maximum value for y is always b, so we now know b. So if we go back to, well, what are we trying to do? We're trying to write an equation for an ellipse. Trying to talk and write at the same time. X squared over a squared plus y squared over b squared equals 1. Okay, so now we need our a and our b in order to get our answer. Well, we have b, so we're partway there. Y squared over 6 squared, so y squared over 36 equals 1. And now we just need to know a, so we could square a. So we have x squared over our unknown. Figure that out, we're done. Okay, so now if we flip back to our index card, said that this equation here I mentioned earlier is how you, between a, b, and c, if you know two of those three, you can use this equation and find the third one. So we need to find a. The reason I wrote it this way is if c squared is always going to be positive. So you have to take a larger number minus a smaller number to get a positive. So if you have a horizontal ellipse, a is going to be bigger. So it'll be a squared minus b squared, because b is smaller than a. If instead we have a vertical ellipse like this, now b is larger than a. So now the equation becomes b squared minus a squared, because b is the larger one. But for us, we have a horizontal ellipse, so it'll end up being a squared, because a is larger, minus b squared. So if I take my equation and say a squared minus b squared equals c squared, and now a is what we're looking for, so I'll just leave that variable in there. B squared, so b is 6, so we'd have 6 squared, or I'm just going to write in a 36, which is 6 squared, equals c squared, so 8 squared is 64. Now if we want to find a squared, we add 36 to both sides. So a squared then equals 100. The real common thing now is people will square root the a and they'll come up with that a is going to be 10 or negative 10. I still find myself doing that. A itself will always end up being the positive one. But the equation is asking for a squared, so you really could have stopped right there. And a squared we know is 100. Otherwise you find the 10, you square it, you get back to 100. But that there is going to be the equation for the ellipse. So if you keep that index card handy, you can kind of take the story problem, figure out what the ellipse looks like, so draw a picture, and just keep going back to those equations. Well, okay, what do I need to find? And then from what I have on my drawing, what letters do I have? And then how do I get from the letters I have to the letters I need? I hope you like ellipses. I think a lot of people end up kind of liking it. But at the beginning they can be really frustrating. That's all about ellipses.